All right, guys, we're going to move into chapter 4. First thing we're going to talk about is just linear versus nonlinear. Okay, you are familiar with a few things in linear, right? Slope intercept form, some of those items. So just identifying if something is linear. So notice we, first one here, 20 goes down to 16, so that's minus 4. To be linear, I need every single one of these moves to be minus 4, right? So this one is linear. That's a good thing. Notice this one, we're going to go up 1, and then it goes up 2, and then it goes up 4. As soon as these numbers are different, this is non-linear, okay, which means I couldn't write y equals mx plus b out of it. So we're just going to test these. That's what we're going to do for the first few problems here. So to go from 0.1 to 0.2, that's an increase of 0.1, another increase of 0.1, and an increase of 0.1. Okay, so you may have seen this before where we put positive on there. We'll just keep that in mind as we work through these. So from 1/2 to 1, that's an increase of 1/2. And then from 1 to 1 and 1/2, so I might have to translate these again. That's another 1/2. That's okay. And that's another 1/2. And this would be 2.5. So guess what? This one is linear. That's a good thing. All right, in the next one, we're going to go from 1 to 1 and 1/2. So it's going to take away 1/2. And if I take away another 1/2, I'm at 1. Okay, so this one looks like it's going to work as well to be linear. Just add some fractions in there. Number 6, this looks like minus 2 and then minus 1. So as soon as I have two of them that disagree, I can say nonlinear. Right? If they happen to agree, I need to work the whole way through the chart of whatever I'm given to prove that the whole thing is linear. All right, so we're going to take that, and now this time we're going to say this is the term number, so term 1, 2, 3, 4, 5. So I'm really just checking if these were x values, I'm checking y values. So this is plus 2, plus 2, plus 2, plus 2. So the same thing, it's just presented in a different format. So this is linear. So x values, y values. So I get plus 2, plus 2, plus 2. All right, so one thing, because we wrote up slope-intercept form, right? Y equals mx plus b. So while we're talking about this, I just want to put this in front of you and say, you know what, this plus 2, that's the change every time. So that's your slope. So we could say y equals 2x. Right? Now, the last thing that I need for this, guys, is I need to know what would go with 0. So if I extended my table back to the left, if these are all plus 2, right? So what plus 2 gives me 5? We know that's 3. And since it's positive 3, that actually builds the equation. We're going to use that here at the end. So I figured now's a good time to introduce that and throw it in front of you. Remember, the y-intercept is when x is 0. So that's how we'll work through these, because I think linear, nonlinear, that's going to be pretty easy for you, because I'm very fortunate to have awesome students. These are all plus 3, right? So let's go ahead and write it. Y equals 3x. So what would go back with 0? So plus 3. What number plus 3 gives me 5? Okay, that's 2. And it's positive 2, so I'll write plus 2. So that's not too bad. Now what I might want to do is say, okay, ask you, can you extend the pattern for me? Okay, so if it's plus 6 each time, well, plus 6 would have us where? At 34, plus 6 more would have us at 40, and then we're at 46. Okay, so we might ask you to extend the pattern. Could you write the equation? Sure. Y equals 6x. If this is term 1, I need term 0. So what number plus 6 gives me 10, and that's 4. So I get positive 4. Okay, so hopefully this is ringing some bells back to slope-intercept form, and we can work backwards. Now here's where we're practicing the idea of getting this 0 term in the beginning, because I might also ask you to extend the pattern but go backwards. So if I'm looking this way, right, this is minus 4, this is minus 4, this is minus 4. Now keep in mind, what you're really doing is you're working with this pattern backwards and saying, actually, if I go only this way, it's plus 4, and this is plus 4. So you get the idea that whichever way you're moving across the chart. So in this one, we notice plain old slope, I would use -4. But if I need you to fill the table in, you're going to add 4 to get 92 and add 4 more to get 96. So the first term is 100. The 0 term, if I need you to write the equation, is now 104. Does it fit the pattern for the bottom? -4, -4, -4. Okay, and I know that might be confusing, but it's based on what you're trying to do with the problem. So again, even though we're filling the table in, could I ask you to write the equation? Sure. Remember what's happening down here to your y values, left to right is your slope, and then we found plus 104 as the starting point. All right, so hopefully those are nice and clear. Otherwise, we'll work on it in class. All right, so what's going on here? +8, +8, +8, +8. So what's my equation so far? Y equals 8x. Okay, so this is term 1, so what would be before it? So what would be before it is 52, so plus 52. So we're going to build up these equations, and now it's saying, what's the 14th term? Okay, y equals 8 times 14 plus 52. Okay, so I want to make sure we get these set up. If you could take your calculator and get whatever you need out of it, that'd be awesome. With the 35th term. So eventually I'm going to plug 35 in for x. So first thing I need to figure out is what's the slope? I get +3, +3, +3, +3. Oh my gosh, I keep saying 3. They're 0.3. 0.3. All right, so we got 0.3x. What would be before this? So what's in the 0 term? Okay, so if it keeps increasing this way I want to decrease. So that means it's going to be positive 3.2. So this gives me my equation in slope-intercept form. And now we're just going to plug 35 in there. So 0.3, 35, 35 plus 3.2. And that'll give us that y value. All right, so a couple more. So this is kind of getting to the application, how we'll use these. These are very generic, obviously. We can't tell what it's about or anything else, but it gives us the process. All right, so we got to get from 103 to 84. All right, so this is definitely subtracting, right? We got 16, 19. So minus 19, minus 19, minus 19. So I got negative 19. We're eventually going to put in 21, but I have to figure out what would be on here. So if I add 19, I'm at 122. All right, just need someone to check the math on that one. I'm pretty sure it's right. All right, we jump over here to number 13. Eventually, we're going to plug in 22. So just to speed things up, I might start to do that with you right now. To get from -2 to -5, we're going to go down 3. All right, so we see that these do follow suit. And then before that, what would be +3 is +1. So we can get our 22nd term by doing that. All right, so these are all given as assumed to be linear equations, so we can work with it that way. So we're definitely going down. How much are we going down? Right, 30, 29, 29. Okay, so minus 29, minus 29. You get the idea that we have those working. So negative 29. Eventually, we want the 16th term, so I'm going to plug it right in. All right, so what do I have to do? I have to add 29. It'd be 102. And then we're going to plug that in and get a final y value. 50th term. We're going to figure out what's going on first. Plus 11. Okay, so I get 11. We're going to multiply by 50. But before that is going to be minus 11. So minus 20. So first, y-intercept that's negative. And that's completely okay. So again, we want to finish these out and get those y values. Okay, so 11 times 50 minus 20. And get your final answers there. All right, so we are going to tackle on some homework onto this one. So that'll also be in your notebook today for homework.